start with the inside function u equals g of x. Then the derivative of this function u is written as du dx is equal to g prime of x. To help us apply the substitution rule, we can treat du and dx as differentials. This gives us the equivalent form for the derivative of u being du is equal to g prime of x dx. If you're not familiar with the differential notation, that's okay. Here's all you need to know for the purpose of applying substitution. When we take the derivative of u with respect to x, we usually write du dx is equal to g prime of x. The differential notation for this is du equal to g prime of x dx. We consider both of these equations to be equivalent. In other words, for the purpose of substitution, we are allowed to multiply both sides of this equation by dx, and in turn get this equation. Notice when plugging u in for g of x and plugging du in for g prime of x dx above. So what's nice about this substitution box is that all you need to do is pick a u substitution, then take its derivative using the differential notation. If you end up with an integral in terms of just u, then substitution is complete. You can just integrate your new integral with respect to u, then plug back in u equals g of x for the final answer. Example 1. Find the indefinite integral of x times the sine of the quantity x squared plus 2. We start by picking our u substitution. We're looking for the inside function, whose derivative is multiplied times the outside function. But even if you don't recognize its derivative being multiplied, that's okay. The key is picking the inside function for the composite function. Once applying the substitution rule, you'll be able to see if it all works out in the end. So we pick u equal to x squared plus 2. Thus, derivative of u with respect to x is 2x, giving us the differential form of du equal to 2x dx. Recall, this differential form came from du dx is equal to 2x. So if you're not used to writing it in this differential form, feel free to write in du dx equals 2x in the line before it. Notice in the integrand, we have an x dx, so we need to divide both sides of our equation by 2 to get x dx on its own, giving us 1/2 du equal to x dx for the final line in our substitution box. We now substitute back in the integral exactly what we have in the substitution box. 1/2 du replaces x dx, and u replaces x squared plus 2. This gives us the integral of sine of u times 1/2 du. 1/2 is a constant, which can be placed outside the integral, giving us 1/2 the integral of sine u du. It's all in terms of u, so all is good. Integrating with respect to u, we get -1/2 cosine u plus c. We now plug back in u equal to x squared plus 2 for a final answer of -1/2 cosine of the quantity x squared plus 2 plus c. Example 2. Find the indefinite integral of x times the quantity of x plus 3 to the 9th. Now we could expand x plus 3 to the 9th, giving us a 10th degree polynomial for the integrand, but that's certainly a multiplication we would like to avoid. Here we make the u substitution of u equal to x plus 3. This gives us du equal to dx, since the derivative of x plus 3 is 1. But looking at our integral, we notice a problem. If we plug these substitutions back into the integral, we still have an x remaining. And we know we cannot have mixed variables once the substitution is complete. This could mean that substitution doesn't work here, but do not fear. We still have one more trick up our sleeve. We just need to rewrite x in terms of u using our original u substitution. u is equal to x plus 3, which gives us x equal to u minus 3. So replace the remaining x, underlined in red, with u minus 3, giving us the integral of u minus 3 times u to the 9th du. Multiply this out, and we have the integral of u to the 10th minus 3 u to the 9th, which is u to the 11th over 11 minus 3 u to the 10th over 10 plus c. Plug back in u, and we have a final answer of 1 over 11 times x plus 3 to the 11th minus 3 over 11 times x plus 3 to the 10th plus c. You're going to learn other techniques for integration, but substitution is the most important one. It is ubiquitous. It's very important that you do as many examples as needed to master this technique. Remember, when presented with an integral of a composite function, think substitution first.
Okay, very good. So this method is called what? It's called the rule of substitution, or the substitution rule, right? The idea is that you introduce a new variable, right? Let's take a look at this problem. Let's take a look at example 1. Okay, this is a new example here, right? Let's take a look at this example. Okay, let's take a look at this example. You see, let me enlarge it for you. Okay, this is x cubed, right? Cosine of x4 plus 2, right? Dx. Now this looks very complicated, right? You have x cubed, cosine inside is x4 plus 2 dx. But no fear. Why? We can use u substitution. Let u equal to this number, this function. Okay? So let me write here, okay? Let u equal to x4 plus 2. Okay, we learned from last test how to find the differential of u, right? Du is what? Du is the derivative times dx. What's the derivative here? Is 4x cubed, right? 2 derivative is 0. So 4x cubed dx, remember? You see from the last test, right? Dx. Okay, now you have what? You have x cubed dx right here, see? Right? So you can divide by 4 on either side. So 1/4 du is equal to x cubed dx. See? Right? Now you can write everything in terms of u here. So this becomes cosine x4 plus 2 is u, right? So cosine u time x cubed dx. X cubed dx is 1/4 du, right? 1/4 du. So x is gone, only u left. Right? Now 1/4 scalar you can put outside. Right? Now in terms of u, antiderivative for cosine u is very easy to find. It's sine u, right? Plus c, of course, right? Plus constant. Because it's indefinite, right? Okay, so final step is to replace u by x4 plus 2. So final answer you have distributed in terms of x, right? U is your intermediate variable you have introduced in order to solve these, right? Yes, it's 1/4 sine of u. U is x4 plus 2. Plus c. Okay, so we have found the answer. Right? The answer is right here. Okay. It's 1/4 sine inside is x4 plus 2 plus c. All right, so we have found the antiderivative, indefinite integral, right? It's this. Now we can fully verify that this is the right answer by what? By taking the derivative. The derivative of this should be equal to this, right? Make sure that you really understand, right? C derivative is 0, you don't have to worry about it. You take the derivative of this function, the derivative should be equal to this by using the chain rule, right? Easy to find the derivative of this function. It's 1/4 right? Sine derivative is cosine by going from outside to inside by applying the chain rule, right? X force per 2. Then you can ignore sine, right? You take derivative for inside function. It's 4x cubed, right? Now 1/4 for cancel out. So x cubed times z, see? X cubed times z, some cosine x force per 2, right? So we have verified that this is the right answer because the derivative of the function is indeed equal to the original function, right? So we have applied the what? The substitution method, right, in order to solve that. Okay, so final answer is 1/4 sine of plus. Right, look at the answer in the text, the same answer, right? See here. Right, 1/4 sine inside is x4 plus 2 plus. Right, by using the u equal to cosine force per 2, that's the right substitution. Okay. This is a famous substitution rule. Okay, so you can what? You can check the answer by differentiating it. Right? So we have already done it. Right? We have already done it. Let's look at this example. Example 2, you have to evaluate square root 2x plus 1 dx. Right? This looks like a square root function, but not quite. Right? Square root function is square root x. But this is square root 2x plus 1, but no fear. Right? That u equal to this. Okay, u equal to 2x plus 1, right? So we can find what? du. Du is 2 dx, so therefore divide by 2, right? So it becomes dx is 1/2 du, right? You divide by 2, so dx 1/2 du equal to dx. Now you can write everything in terms of u, right? So this becomes square root u, and dx is 1/2 du, remember, right? 1/2 scalar you can put outside. So write this as a power function, u to the power 1/2, right? Then you can use the formula for the antiderivative, right? U to n, remember? It's 1 over n plus 1, so 1 over 3/2, u to the power n plus 1 is 3/2, right? Simplify that. This is 1/2 times what? 2 over 3, so it's 1/3, right? So the answer is 1/3. Replace u by 2x plus 1, so 1/3, 2x plus 1, 3/2. Okay, the right answer. Okay, so we have found. Okay, let's look at this example here. How to find antiderivative for this function. X over square root 1 minus 4x squared dx. Okay, now this is, again, this is the u substitution method. Then u equal to what? U equal to 1 minus 4x squared inside square root. Okay, see, this is very easy to substitute. Then u equal to 1 minus 4x squared. So we can solve for du, right? Du is the derivative of the function times dx. The derivative is negative ax, right? Right, du is negative ax. So you can solve for divide by what? Negative 1, because here is x times dx, right? So what's x times dx? Divide by 1 over negative 8, right? Divide by negative 8, right? So x dx is negative 1 du, right? Now you can what? You can convert everything in terms of u, right? So this is x dx is negative 1 du, right? Negative 1 du. 1 over x dx has been absorbed into u, right? And this is square root u, right? Again, this is a power function, it's u to the power negative 1/2, right? You can apply the antiderivative for the power law, n plus 1, remember? This is u to the power 1/2 square root u, and 1 over 1/2 is 2. So it's negative 1/4 square root, u is 1 minus 4 squared. So we have found by using the substitution method, the rule of substitution, right, to get this answer. Okay. Right, negative 1/4 square root 1 minus 4 squared. Easy, right? Easy. Okay. And let's look at this. Example 4. We have to do lots of examples in order to understand this method, right? Let's look at this example here. How to find antiderivative for e to 5x. We know how to find antiderivative for e to x, right? But here is e to 5x. But that's also very easy. You replace u by what? 5x. right? So use the U substitution method once again, right? You use 5x and solve for du. Du is the derivative of 5x, which is 5, right? So du is 5 dx. Divided by 5. So dx is 1/5 du, right? Now you can write everything in terms of u, right? See, that's the way. E to 5x is e to u, and dx is 1/5 du, right? So 1/5 is scalar put outside, and antiderivative for eu is a piece of cake because it's eu itself, right? Now replace u by 5x. Okay, so final answer is 1/5 times e to 5x. Right? So easy. It's easier to verify this is the right answer. You take the derivative. What's the derivative of this? It's 1/5 times e to 5x times 5. 1/5, 5 cancel out. Indeed, is equal to what? E to 5x. Right? E to 5x. So this is the perfect answer. Okay? Perfect answer. Right? Perfect. So we have done a lot of examples, right? A lot of examples. Now let's look at this example. Example 5. Okay. We've got to do a lot of examples in order to understand, in order to be familiar with this method, in order to master this method, right? Let's look at this now. Please solve this by yourself without looking at the answer, okay? You can solve it by yourself. How to find antiderivative for square root 1 plus x squared times x to the power 5th dx. Please solve this problem by yourself. How can we solve this problem? Again, you want to use the U substitution method, but you have to remember, you have to write everything in terms of U. X should not be left behind, right? It's very easy, like U equal to 1 plus x squared, okay? So that U equal to, so let me write down here. I want to show you, that U equal to 1 plus x squared. Right? So du is the derivative times dx, then the derivative is 2x, right? 2x dx. So therefore, divide by 2, right? So you will have 1/2 du divided by 2 equal to x dx. Okay, so this can be written as square root 1 plus x squared is u, right? U times x fourth times x dx, right? Because x fifth is x 4 times x. What's x times dx is 1/2. Sorry, this x times dx, this x, okay? X dx. So x dx is 1/2 du, right? 1/2. So remember, I split x fifth into what? X fourth times x. So x dx has been absorbed into 1/2 du. So, but that's not very nice. Why this is not very nice? Because you have two variables here, right? You have u and you have x. This makes life more complicated. So you have to what? You have to write x fourth in terms of u, right? That's a key step. But that's easy now. Why? Look at here. There's the connection between u and x squared, right? So you can solve for x squared. So u minus 1 on either side, right? Now you can square both sides, right? So on the left side is u minus 1 squared. On the right side is x squared, which is x fourth. Right? So finally, we can see that x fourth is u minus 1 squared. Aha! Now you can continue. Right? 1/2 squared put outside. So 1/2 is, now this is what? It's equal to u. The x fourth actually is what? U minus 1 squared, right? U minus 1 squared. Du, right? Du. So no x left. Everything has been written in terms of u. Right? So we have 1/2 antiderivative or indefinite integral square u times u minus 1 squared du. Now that's easy. You expand and distribute, you will have the final answer. Okay, so let's take a look at the steps in the textbook. See here, right? It's 1/2 square root of u, right? Now expand these. That's easy to expand. U squared minus 2u plus 1. The du is from here. Now what's next? You distribute, right? Inside, okay? So this is u to the power 1/2, remember? Right? U to the power 1/2 times u squared is 1/2 plus 2 is u to the power 5/2, right? Now u to the power 1/2 times u is negative u to the power 3/2. U to 1/2 plus times 1 is u to 1/2, right? To u. Now you can see that this is difference. This is sum, right? So therefore you can do term by term, right? And try to do term by term. So for the first one, you got to remember the basic formula, right? So remember, u and du. What's antiderivative for u to the power m is 1 over n plus 1, remember? Right? The u to the power n plus 1 plus a certain constant. For n not equal to -1. N equal to -1, the formula is different, right? Okay, now here n equal to what? 5/2, right? 5/2. So 5/2 plus 1 is 7/2. 1 over that is 2/7, right? Now this is 3/2, right? 3/2 plus 1 is 5/2 and 2/5, right? These two come from here. This is 1 over that, 2/3, right? So you can simplify, right? By doing distribution. Okay? You can simplify further. Right? You distribute 2 to cancel out. So it's 1/7. What's u? U is 1 plus x squared, 7/2. Now this is what? This is 1/2 to cancel out, right? So it's 2/5. And u is this, right? 5/2. Now 1/2 cancel out, it's 1/3. U, what's u? U is 1 plus x squared, right? 3/2. So that's the final answer. Okay? And answer is this. Right? And answer is this. Right? No u left. Everything should be written in terms of x. Right? So we have finished. Okay? Okay, let's look at one more. In number 6. We have done so many examples now, right? Number 6. How to find these? Antiderivative for tan x dx. Okay, find antiderivative for tan is not equal to secant. Okay, secant wrong. Secant derivative is secant times tan, not tan, right? So you got to use what? You got to use famous identity for tangent. What's that? So let me write it here. This is equal to tan sine over cosine, right? All right, everybody knows that tan is sine over cosine. This is a famous basic identity from math 1126, right? Now you can what? You can introduce u equal to sine does not work because if you let u equal to sine, suppose you want to let u equal to sine, let's see if it works or not. It may not work, right? So du is what? Du will be cosine x times dx, right? But unfortunately, this cosine is in the what? Is in the I don't know what happens. This cosine is in the denominator, not in the numerator, right? So this does not work. Okay, so you have that u equal to cosine. It works. Okay, so that u equal to cosine. This substitution works. Why? Because du here, du is cosine derivative is negative sine, right? Negative sine x dx. Right? Now you can see that sine x dx is right here, right? See? That's why this works, right? You can write this as 1 over cosine x is u, right? It's u. And sine x dx is negative du, right? Negative du. See? It works perfectly now, right? Okay. There's an antiderivative for 1 over u, negative du. Negative is outside, like the negative is scalar, negative 1 actually, right? Huh? Du, okay. Now, what's the antiderivative for 1 over u? That's the formula from the table, right? Everybody knows that. You see, negative ln absolute value, don't forget, okay? Plus c. Now we're almost done. Replace the u by cosine x, okay? Go to negative ln absolute value, okay? U is cosine x, right? Huh? What's this? Plus c, okay? Plus c. Now, in some textbook, you can put a negative sign up, right? Because by the properties of log, you can write this as ln cosine x to the power negative 1 here, right? And now cosine x to the power negative 1 in secant, right? Because 1 over cosine is secant. So you can write this as in a neater form, right? So it's ln absolute value secant x plus c. So we have found the answer, okay? In ln absolute value secant x plus c. All right, so let's take a look at answer in a textbook. It should be the same answer, I hope. Take a look at. Right, same answer. See, right? So this is the final answer. See, right? This is a new formula now, right? Antiderivative for tan is ln absolute value secant x. Right? See, right? So we have found in the future, I will just use this formula without doing it once again, right? Because everybody knows how to find antiderivative for tan, right? It's ln absolute value secant plus, right? So this is the answer. Okay, this is the answer to antiderivative for tan by using U substitution method, right? This method called the U substitution or the rule of substitution, right? Okay, so let's turn to next page. So we have finished lot of examples, right? Lot of examples. Next page. Okay, now this is for definite. We have done for indefinite, but for the definite, it's, I don't know what is happening. Yeah, okay, goodbye. Okay, definite integrals, right? Now you can do the same thing for the indefinite and same thing for the definite. The ideas are very similar to each other, right? So let's take a look at the definite case. Okay, the substitution rule for definite integrals. Okay, the idea is similar, but you have to change what? You have to change these in terms of, okay? So let's do one example here. Okay, let's do one example here. Okay, let's take a look at this. Okay, evaluate this. Okay, evaluate, this is definite, right? Lower limit is 0, upper limit is 4, and inside is square root 2x plus 1. Let's use the same idea, that u equal to 2x plus 1, and let's do it. Okay, let's do it. Okay, so set u equal to 2x plus 1, right? Okay, we use U substitution method. So solve for du, right? What's du? Du is the derivative times dx. Remember from the last test, right? Derivative is 2 times dx. Okay, so now you can write everything in terms of u, right? So this becomes square root 2x plus 1 u times dx. Dx is 1/2 du divided by 2, right? 1/2 du. Okay, but For the definite case, you have to change the lower limit and upper limit by using these, okay? By using these connection between E and X. Now, let's look at X equal to 0. Let's see what happens. If X equal to 0, let's see what's for U. U is 2 times U is 2 times 0 plus 1. Replace X by 0, right? So the answer is 1. Okay? Now X equal to 4, right? Is upper limit. What's the value for U? Solve for this, right? So U equal to 2 times 4, right? Plus 1, which is 9. So the new lower limit under U is 1, right? And the new upper limit under U is 9. Okay? So you have to find the integral 1 to 9 square U times 1/2 du. So that's easy to find, right? 1/2 is a scalar put outside, and antiderivative for U to power is U to power 1/2, right? So easy. 2/3. U to power 3/2, right? 1/2 plus 1, 3/2. Now you don't have to change it back to X. Just evaluate this under 9 right away by using FTC, fundamental sum calculus, part 2, right? Okay, do not change U back to X anymore. For the definite, you evaluate this integral, evaluate this value, right, under U, because you have already changed the older limit to 1 and then older limit 4 to 9, right? So you evaluate this under U by using FTC, part 2, right? Fundamental sum calculus, part 2, okay? Follow these. What is the 9 from? Okay, here, see? Here, right here. This one 9 come from. Right? Here, you have X equal to 4, right? By using this connection, 2 times 4 plus 1 is 9. So this is a new upper limit. 1, X equal to 0 is old limit, right? Low limit. Put 0 inside, so U equal to 1. This is our new low limit for U, right? For U. Okay, so this is what is 9 come from? Right here, right? Thank you. You also be very welcome. Okay, thank you. Okay, now you can find the answer by using FTC2. Let's do it. So this equal to 2 cancel out, right? It's 1/3. And replace U by 9, right? Upper limit minus U by 1, right? Low limit, right? Now easy, right? This is 1/3. 9 to the power 1/2 is 3. 3 to the power this is 27, right? Minus 1. So we have found the exact answer. The 26 over 3. Okay, so remember for the definite, the answer got to be a number. For the indefinite, the answer is a function plus c, right? But for the definite, the answer must be a number, right? Must be a scalar number. So the answer is 26 thirds. Okay. So let's take a look at from the textbook. Okay, let's hope the answer is signed. Right? This is you get 9, right? See here. Right? Same answer, 26 over 3. Right? You replace 0 by 1 and using this section, right? And change the new low limit, change the low to 1, upper limit to. Now everything has been written in terms of U, right? The answer is 26 over 3. Right? So remember, okay, for the definite, you just evaluate this U under new low limit and a new upper limit. Do not change U back to X anymore. For the indefinite, you have to change U back to X, right? But for definite, the answer is a number. You have to replace. You have to evaluate this number, okay? Evaluate this number. For the definite, okay? For the definite. Now let's look at another example. Number 8. Let's solve this. Okay, let's solve this. Same idea that u equal to, right? Okay, so that u equal to 3 minus 5x. Okay, what's next? Solve for du, right? Du is -5 times dx. Okay, because the derivative of this function, so its derivative is 0, -5x derivative is -5 dx. Okay, now you have to change the upper limit and the lower limit. X equal to 1. Let's see what happens. Solve for u, right? So u equal to 3 minus 5 times 1, right? Will be 3 minus 5. Right? So the new upper limit, sorry, the new low limit is -2, right? Okay. Now find the new upper limit for u. Right? So here all the upper limit is equal to 2. Let's find the u. The corresponding value for u is u equal to 3 minus 5 times x2, right? So the new upper limit is -7. Okay, -7. Now this is 1 over u squared, right? Dx divided by -5, right? So dx is du over 5. Right? Dx is divided by -5, right? It's negative d over 5. Now this is scalar plus side, right? -1/5. From -2 to -9, -7, sorry. All right. This is what? Utah -2. All right. The antiderivative is very easy to find because this is a power function for the antiderivative, right? So you see -1/5 by using FTC now, right? 1 over -2 plus 1 and the u to the power -2 plus 1 by FTC power 2 from -2 to -7.
Hi, baby girl.
Okay, so this will be
You need to stop that.
1 over -1. Okay, -1/5.
Now. Let me see this.
Right?
Let me see your face, baby.
You see u to the power -1 1 over u, right? So 1 over -7.
Yes, it's a star.
1 over u, right?
Ah.
Cool. Please turn off the human audio. It's very annoying. Right? And everything just doing some calculation by using arithmetic, right? So 1/5 is audio 1/2, right? Minus 1/2. Right? Simplify, okay?
I got the version of 3A.
Ha ha ha. It's 14. Right? 7 minus 2 is 5. Right? So the answer is 1 over 14.
I don't even know what it's up. I have to call her. I have to see if he's gonna finish it out. So I can.
Okay, 1 over 14. Right? Okay, that's answer 11. Who is it? Mute, possibly. Okay, good. So 1 over 14, right? 1 over 14. So our answer is 114. Okay, 114. By using older method, use substitution method. Yes, I hope you use the same answer in the textbook. Let's verify. The answer is 114. Haha, same answer. See, 114. Right? 114. Okay. So is a number, right? So we have found that this is 114, right? 114. Easy. Let's do one more. Okay, let's do this example. Okay, so everybody please try this example by yourself without taking a look at of the textbook. Okay, without looking at the textbook. Please find the answer. From 1 to e ln x over x dx. Please solve this by yourself by using U substitution method. So what's U here? U equal to what? Let me give you a hint. U equal to ln x. Okay, the U equal to ln x. It works. Okay, the U equal to ln x. Okay, it works. Okay, I guarantee that it works. Okay. Okay, so what's the deal? You have to find, right? You have to find. D is the derivative times dx, log x derivative 1 over x, right? Times dx, don't forget, okay, times dx. Now it can be simplified, right? So that's equal to ln x is u, right? And the one, this is 1 over x times dx, which is du. Easy now, right? Du. Now don't forget to change the low limit and upper limit by using this connection. Okay, what's the new low limit? X equal to 1, right? Solve for u. So u equal to log 1, which is 0. Okay, so the new low limit is 0. Now what's the new upper limit? Oh, the upper limit is e, right? So x equal to e. We want to find what's the value for u. Corresponding value for u equal to ln e, right? ln e is 1. Everybody knows that, okay? Okay, so the new upper limit is 1, not e anymore, right? Because we have changed that for u, right? Now this is easy to find. Antiderivative for u is 1/2, right? By using FTC part 2. Right, so 1 square minus 0 square, which is 1, right? The answer is 1/2. Okay, the answer is 1/2. Okay, 1/2. It's a number, right? This is a number, 1/2. Okay, so we have finished. Let's take a look at the answer in the textbook. Got it? I hope. Right, see 1/2 here. Right, 1/2. See, the older upper limit is e. Now the new upper limit is 1. Older low limit is 1, and new low limit is 0, right? So antiderivative for u is u square root 2, and 0 to 1. This is FTC, right? Part 2. The answer is 1/2. Okay, 1/2. So we have found the answer, 1/2, right? It's a scalar, right? Okay, so we have finished everything, right? We have finished. That's the meaning for this, right? This is the area, right? The area from 1 to, remember, the log x, the graph is this, right? From 1, because log 1 is 0, so this is 1. And log e, right? From 1 to e, right? This is the picture, the graph. So what's the meaning for this? This is the area, right? Okay, so we know that the area here is 1/2, right? 1/2. Right? The area is 1/2. So you see the area. You see area is 1/2. Okay. So we have finished. Do we have more pages? Let's take a look at it. Oh, this is symmetry. Symmetry is also easy to understand, right? If x is an even function, then you can see that let's take a look at the picture. It's easy to see from the picture here. This is an even function, right? What the even function mean? It means that what? The graph of this function is what? Is symmetric with respect to y-axis, right? So the curve, this curve, right? This curve is an even function, right? Is an even function. Okay. See, because you can use this as a mirror, right? So the left side and right side are mirror image to each other, right? So this is called even function. So for this function, it's even, right? So now you want to find what? For even function, okay? For even function, you want to find the integral from negative a to a, right? Even function, this side and this side are sine, right? So you have two of them, right? This plus this, right? So these are sine, right? The 2 from 0 to a, right? Okay, so for even function, if you go from negative to a, right? What the final effect is 2 times from 0 to a, right? Because why? Because the left side and right side are sine. The area, right? The area, okay? Because they are symmetric with respect to y-axis, right? So the left area and the right area is sine, right? So therefore, if you want to find the total area, you see 2 times this, right? 2 times. Now you can find the area for the right side, right? And 2 times this will get total area. Okay. Now for the order function, things are slightly different, right? This is for the order function. Okay, for the order function, the graph is what? The graph is symmetric with respect to the origin, not with respect to y-axis, right? So this is the order function. Now you can see that from negative to a, they cancel each other because this is what? This is negative value. This is a positive value, right? They are sign, right? Off by sign, right? So then net area is 0, right? Net area is 0. So from negative a to a, fx dx, if fx is odd, then the answer is 0, right? Because they cancel each other. The negative side and the positive side cancel each other, right? Net area is 0. Let's look at this, right? From this is even function. Why is even function? Because you replace x by negative x, f negative x equal to fx. That's sign, right? So therefore, if you want to evaluate from negative to 2, you get what? 0 from 2, and 2 times of that, right? And you can see that this is easy to find antiderivative. This is 17x7, this is 1, right? Now you can see that replace x by 0, everything is 0, right? So replace x by 2 by ftc, right? And 2 times this will be, the answer is 284/7, okay? This is even function. For all other function, the answer will be 0, right? So this function. The denominator is even function, but the numerator is odd function, right? So you replace x by negative x, f negative x will become negative fx, right? So this is odd function. So therefore, this is 0. From negative 1 to 1 is odd function, right? So the answer is 0. Okay, so you don't have to know how to find antiderivative for this because the answer will be 0. Because it's odd function from negative a to a, right? The answer will also be 0. Actually, the antiderivative for this function is very hard to find. We don't have to find, right? Because this is odd function, this from negative a to a, right? Always be 0. Okay, will always be 0. Okay. Okay, this is, what's that? Oh, this is exercises. So we don't have to worry about that. So we have finished. Okay, we have finished. Our time is 7:31. So we have finished slightly ahead of schedule, ahead of time, right? Ahead of time. So we have finished everything in this semester, right? So we have tomorrow, remember 4 sections, okay? 5.1, 5.2, 5.3, 5.4. will be covered for tomorrow's recitation and quiz, right? And the Thursday, I will give you a review for the test. And Tuesday next week, we'll have test. Please sign your name, okay? Before you leave, please sign your name. Don't forget, Thursday we'll have a review, okay? Very important, okay? Don't miss the review, okay? Unless you want to, you don't want to do well on the test, okay?